reviewing the homework because, and a lot of you didn't do it. How do you not even know that we had homework?
I forgot. Well, I actually didn't go. A lot of you.
Okay. The meeting is being recorded by the host or participant. Got it. I'm recording it. Okay, on Teams, if you were on Teams, you would have seen the homework. But regardless, it doesn't matter. Which test? Only if you're careful. It's gonna be okay. All right, so give me 1 second. I'm trying to get a test for a student here, if I can find it. And I should put this extra credit in for these girls, right? Here we go. I'll put this in at the end of class, so don't forget. It's gonna be okay.
I mean, I'll probably be upset, of course.
It's for, yeah, no, it's just now. Here we go. I found it.
Oh, my eyes out.
I have the formulas in the little paper.
Just get it from your remote and write it down. Good, yes. All right, yes. If I did, I would let you. Check my printer to see, but I don't think I have. All right, guys. Settle down. Look. Okay, so Christian was telling me he didn't have an issue with independent or dependent, right? Like you could tell them. Okay. But you had issues with.
No, the only issue that I had was the 3 and 4. I don't know why.
All right, so let's do this together. So let me sit next to Brianna. Oh, you want me to sit next to you?
Next to me.
Oh my gosh. Okay. So let's begin. Let's look at 3 and 4. Now, 3 and 4 by itself, if I look at it, I mean, I can give you the definition, and that's probably better, but it says if two events are not independent, and in reality, you're supposed to write if two events are independent, the probability of A given B must equal the probability of A. And that's how you make this true, because it was false the way it was written. It was false the way it was written. If events A and B are dependent, then the probability of A and B equals the probability of A times B. Well, if that's number 4, no. To make this correct, you would have to write it like this. You would have to change that word dependent to independent. Okay? That's what you would have to do. Yes. And now, so I might as well, because you have notes out, I might as well take some time. And over here on the right here, write both rules. And it works something like this. Huh? Because we're in school. We come to school in a bus. Don't you come to school in a bus? If, oh no, let's write it better. Yeah, okay. All right, if events A and B are independent, right? If they are independent, then the probability of B given A equals the probability of B, or the probability of A given B equals the probability of A. Else they are dependent. That's one of the rules. It's not really a rule, it's more like a definition. All right, did I admit Jason?
Oh, so you're allowing another.
I knew you were gonna say that.
Got it. Got it. Got it.
I didn't have to say I was gonna do that, but I said it. But you would have seen it anyways.
Got it. Okay.
Hello, Jason. How are you?
Ask me how he is.
Hi, mister. I'm doing good. I had no idea there was a Zoom meeting.
Oh, he didn't know.
Alex inspired me to create a Zoom meeting for him.
Alex is fine.
Thank you. Thank you. Thank you. Anything. She's just mad because I'm special, you know? That's it.
That's so mean.
What do you think about it?
All right, so let's talk about the second rule. It's called the multiplication rule. Do you guys want me to do this in rainbow color? Here's the multiplication rule.
Take to one color, bro.
All right, so the probability of A and B must equal the probability of A times the probability of B given A, or you can also write that the probability of B times the probability of A given B. So those are the two ways we can look at the multiplication rule. Okay, now there's a second
Mister, if
part.
I'm gonna be honest, I am completely lost.
It's okay because when I get through it, once I go through this, I think you're gonna be just fine.
All right, go on.
So now we say if events A and B are independent, then the probability of A and B equal to the probability of A times the probability of B. And that's the full multiplication rule. And that allows you to do numbers 3 and 4. But the thing is, you might not understand what's happening, right? You might look at this and you're like, I don't understand what's happening because you missed last class, you didn't watch the YouTube lecture, you didn't do the homework, or a combination of any of the following reasons I gave. Okay? So let's try and gather some understanding together. So it's almost as I'm teaching last class all over again, and that's fine. Even though I don't really feel like doing it, I'm gonna go ahead and do it. What's wrong?
I was writing that.
Okay, I'll go right back. Don't worry. It's on the board too, by the way. On the left. Yes, it is already on Teams, and I'll do it next class. So don't worry. So you guys will get your review on quizzes. I'm not trying to hurt anybody's grades. I want you to be strong. No, I'll go one more class to review and then we'll have the quiz. Now I am sensitive to people with their COVID stuff, even though some people may have COVID.
I don't have COVID.
Okay. Okay, but it doesn't matter. Like all of us are gonna die someday. So.
Okay.
All right. It's like every day I discuss that, but I can't help myself because I even listen to that when I'm in the gym.
Okay, now you're just being weird. How do you listen to that while going to the gym?
It makes you want to work out harder because you have to enjoy the time you're right there while you're alive.
I mean, yeah, but won't you get like sad or like start thinking about life?
No, it makes me, I don't think about it sadly anymore. I think about that I have very limited time to achieve my goals. So make it happen,
Smart.
make it worth, make every little second count.
Got you, smart.
All right, guys. So now let's go ahead and talk about conditional versus the event itself. Yeah. So now let's go back to what we talked in the other class. Last class we said, hey, so Brianna, I'm gonna talk to you. I could talk to Alex, but because I see you and I don't see Alex, I'm gonna talk to you because you also get jealous. So I have 52 cards in my hands right now. You're gonna pick the first card, and it's a king. Okay, and you're gonna hold it in your hand. We call this without replacement. All right, so which card are you holding in your hand right now? A king. How many cards do I have now in my hand? 51. Now, did the event king happen? Yes, because you're holding in your hand. So now I ask you, hey, Brianna, what's the probability of queen given you got the king? And you would say what? How many queens do I have in a stack of cards?
13.
No, you have 4.
I don't know that.
It's okay, okay. So we have 4 queens.
Oh.
We have 4 queens, we have 4 kings, we have 4 J's, we have 4 10s, we have 4 9s, we have 4 8s, we have 4 7s, we have 4 6s, we have 4 5s, we have 4 4s, we have 4 3s, we have 4 2s, we have 4 aces. Okay, so what's the probability you're gonna get a queen given you got a king? 4 out of how many? No, 51. 4 out of 51. Now, if we would have started normally, what would have been the probability of queen by itself? Now, did you see what the event king did to the probability of queen? Did it change it? Okay, this is super important. Event king happens. What's the probability of queen? Out of? Did king affect the probability of queen?
Yes.
Therefore, in cases like this, where the probability of the conditional, here's the conditional queen if king first is not equal to the probability of queen, they are dependent events. And that's where the rule over here that we write at the beginning, when it slides all the way over there, come on. If events A and B are independent, then this is true. If it's not true, then they are dependent.
At this time, the next 3 clubs need to report to the gym for their club picture. Just so everyone knows, we are not taking any club pictures during lunchtime. So these are the last 3 until after lunch. Club GSA, Go Let's, and Gridiron Girls, please report to the gym at this time. And club sponsors, remember to take your class with you as there is no class coverage. In addition, all juniors, please listen up. Perf Jones is inside the cafeteria. Perf Jones is here to accept final payment for your junior ring, as the final payment is due before January 10th, and ring ceremony is next Thursday, January 13th. If you have your form of payment, please make your way to the cafeteria during your scheduled lunchtime. Attention all students who drive to school. If you would like to purchase a car decal to park in our student parking lot, please come see Lisa, our school treasurer, who's located in the back of the office during your scheduled lunchtime or after school. Thank you.
All right, so let's continue. So did you see that, Brianna? So we say 2 events are dependent if one event that happens first affects the probability of that. Now let me give you an example right now of independent events. Notice that an independent event will show that both probabilities are the same no matter what. If B happens and then A, and if A happens by itself and there's no change in probability, then B didn't affect A. So let's go through that example. And I know it's kind of repetitive, but it's okay because I'm going to put the effort. I think Brianna deserves me to put the effort to try and make sure she learns. Alex, I started to Zoom for him. All right. So now look, Brianna, you're going to roll a die. Do you know what a die is? Yeah, a little cube with numbers 1 through 6 on it. You're going to roll it, right? Let's say you get what's your favorite number from 1 to 6? And that's what I was going to say too. All right. So you got a 3. So you get a 3, right? And now you're going to flip a coin. When you flip a coin, how many possible results do you have? 2, heads or tails, right? So now I'm going to ask you, hey, Brianna, what's the probability of you getting heads when you toss the die? Toss a coin, given you just rolled a 3. Could you tell me what the probability is going to be? Okay, let's try it one more time. You roll the die. So do like this with your arm, but do it right. Come on. What result came out? Now, pretend you have a coin on the tip of your finger right now. Do this. Now flip it. What's the probability you're going to get heads on that flip, given you rolled a 3? All right, let's try it. Let's try it without rolling the die. All right, let's try it again. Instead now, hold a coin right here and flip it. Tell me what's the probability of heads? Which is half, right? Okay, good. Now let's try again with rolling the die. Let's roll a die. You got a 3, right? And now we're gonna flip the coin. What's the probability you get heads given you just rolled a 3?
Oh,
Exactly.
oh, so what's the point of telling me to die? What was the point of that? At all?
To show that they don't have enough.
Look at the board.
Oh.
Do you see that the event 3 had no effect on heads? And that's why it's independent. When the conditional and the original event have the same probability, that means that the condition didn't affect the event. Therefore, they are independent. Got it? Yeah, please write that down. But I want to do one more example, which is super important for me to do. And then we're going to go into the homework. Okay? Well, she's not taking a picture. I should just text you or something. Okay. Bro, I was again today at the gym at 5.
Why? I went to the gym.
Yeah. If I could have been at 4, I would have been at 4. Because I could get better workout. Waking up at 4 in the morning, no problems, no alarm needed.
Listen, let me tell you how today I woke up at 5 in the morning.
Talk to
It
me.
was 6. And I woke up to get ready. And I told my sister, we drive to school. And she was like, but it's 5:40. And I'm like,
But why do you, oh, you just made a mistake.
yeah, I thought, I looked at the clock and I thought it was 5. I thought it was 6, but it was 5.
Are you sad?
No, I just slept again. I was like, you know what? I'm gonna go
You
back to
did
bed.
not write in your journal or meditate or read?
No, I slept.
All right. Yesterday I was asleep about 10 o'clock.
Oh, that's super good.
So 11, 12, 1, 2, 3, 4, 6 hours? Not
You
bad.
know what I was doing at 10 o'clock?
What are you doing?
Looking for a law competition.
All of us.
Oh my gosh. All right. Brianna, I got an extra example for you. I have 52 cards. You pick one. It happens to be a king. But this time, you don't keep it in your hands. You give it back to me. So we call this with replacement. And now I ask you, hey, what's the probability of queen giving king? And you're going to say what? 4 out of 52. And now I ask you, what's the probability of queen by itself normally? 4 out of? So did the event king in this case affect queen? No, because we put it back in the stack. Therefore, we reset all the probabilities. So in this case, with replacement, we would say independent, because the probability of queen given king equals a probability of queen. Make sense? And that's how we take care of this rule that's on the board here. Well, you got to try to make the class entertaining, right? You can't say that I stick to just statistics the whole class, right? Okay, there. Because that would be super duper boring. So we have to meander a little bit, but it doesn't matter. Okay.
I noticed in each of your recordings, you always mention that we're gonna die. Like I'm always writing down notes while you're talking in the recording. He's like, You guys know we're gonna die, right? I'm like, okay.
What I want you to, what I want to emphasize is I want to emphasize a few things. Number one, you have, look, right now, this very moment, everything is good, so it's easy to smile. Okay, but regardless, that's why you should be appreciative. You should have gratitude. And right now, you should be as present as you can be in this class. And in every one of your classes. Because it's a miracle. But you don't see it that way. You just take it for granted. It really is a miracle. Be careful. So that's what I'm trying. Look. Okay. Does it seem I am trying to remind myself of these things constantly. And through that, maybe you get it. Does that make sense? So I'm trying to live that. Does that make sense? So that perhaps other people can live it too. Does that make sense? Whatever.
So by you saying that we're all gonna die, all the time, it's like you saying to appreciate the little things.
Yeah.
Small little special ways.
Appreciate everything. Appreciate your parents today. They might not be around.
Forever.
Your head rubbing against the disc.
Everything is appreciate everything. Appreciate it. You'll appreciate this class, appreciate the opportunity you have to learn this, all that. Okay.
I appreciate you.
I appreciate you as well.
That's how you know he wants extra credit.
No, do not attach ulterior motives to that. We
Trying a
do
little bit too hard.
our homework.
Rihanna, just because you're mad.
All right, take a look at the pickup trucks problem there. In a survey, 510 adults were asked if they drive a pickup truck and if they drive a Ford. They were asked two questions. Hey, do you drive a Ford?
Yeah.
I drive a Mercury, which is a Ford. Okay, I like Fords. Right. The results show that 1 in 6 adults surveyed drive a pickup truck. So I can write right now. Brianna, can you give me a letter for a pickup truck that I can use? F? Wait, for pickup truck, you would use F? Wouldn't you use like T for truck?
There's gonna be, you need to use.
Okay,
F
wait, but we need to
for
use
Ford.
F for Ford, but for a pickup truck.
P,
P
Brianna,
can work.
P.
I don't want T.
So which one do you want?
No, I don't want T.
Tampoco.
I want the
How about-
All right, Brianna says pickup truck is T. So, so what is the probability of pickup truck? 1 in 6, right? So right there, 1/6. Okay. Now, then it says, and 3 in 10 adults surveyed drive a Ford. So the probability they drive a Ford is 1/6. And some people can't see it in this fact. So now, well, sorry, 3 in 10. 3 in 10. Sorry, I misread that because I'm stuck somewhere. So 3/10. Now, the most important thing is what the next sentence will say. The next sentence says, of the adults surveyed that drive Fords, 2 in 9 drive a pickup truck. Now, this is a conditional. So if you drive a Ford, the probability you drive a truck is 2/9. So they said it backwards. They're saying the probability you drive a pickup truck, given you own a Ford, is 2/9. And understanding that, being able to take that from that sentence will allow you to do the problem or not. If you can't do it, you cannot do the problem. And you will fail that particular question or maybe the whole test because you know nothing.
And then you'll be a failure, and then you'll have to go to college. And you're refused for, and then you just die. Sad and poor
That's what I've learned in this class.
and lonely and depressed.
Don't be lonely or depressed.
Rihanna, what are you talking about?
That's what he reminds me of.
I'll put a video for you guys once we're done. You're gonna love it. This was the one I listened to this morning. It's really mean. All right. All right. So look at A. It says here, find the probability a randomly selected adult drives a pickup truck given that he or she drives a Ford. So A says probability of truck given Ford. Well, guess what? That's 2/9 because it was given in the question. So you don't have to compute anything there because it already was given to you. Okay? But you had to be able to decipher that from the question itself. Okay? So let's take a look at B. And again, you read it. Find the probability that a randomly selected adult drives a Ford and drives a pickup truck. The probability of Ford and truck. So what is that? Well, we got to go back to our multiplication rule here. We have a rule here. So I'm going to go ahead and write that rule under it. The rule, the multiplication rule is probability of A and B must equal the probability of A times the probability of B given A. So all I do now is I replace the A with the F, the B it's Lydia. I told Lydia there wasn't a Zoom.
Add Lydia to the Zoom right now. Oh my God.
Let me write to her. Wait, I want to reply to her no.
Block him on Zoom. No.
Okay, so now I'm gonna replace the A with the F. So now here I write F, and then here I write T given F. So that's what the probability of Ford and truck is. It's equal to the probability of Ford times the probability of truck given Ford. What's my probability of Ford? 3/10. What's the probability of truck given Ford? 2/9. So this comes out to 6 divided by 90. You're not going to stop, Lydia, are you? Oh, she just put thumbs up. So she sits in the back and she's very nice and quiet. I've never heard her get jealous about anything. So there's the answer, 6 out of 90. That reduces to 1 out of 15 if you're interested. And we're kind of almost done with the question because now we got to do part C, which is really easy. But what I want to do with you guys is I want to explore this question a little bit further before we do the next question, number 15. How do you pay attention in class when you don't want to? How do you force yourself to write notes when you don't want to?
What are they gonna mean?
How do you listen to music that is appropriate? What music are you listening to? Are you listening to any music right now? Are you okay? So what are you listening to? What would you listen to if you were listening to something?
Listen, I'm listening to Kanye.
I would listen to Taylor Swift.
Huh? I'm sorry to hear this.
What would you
Actually, I'm
listen
listening.
I'm gonna show you later.
to? You look like you listen to like jazz. Classical.
No, it doesn't.
Like
right.
classical
He's
music.
listening to jazz on his runs.
Are the events driving a Ford and driving a pickup truck independent or dependent? Well, let's see. What's the probability of truck? 1/6. What's the probability of truck given Ford? 2/9. Does probability of truck given Ford, does that equal to probability of truck? No. So they are D, and that's it. We always have done that. What are you confused about? But do you understand this or not?
It's not a question.
Yes.
I think it's pretty
I
simple.
understand like what you're doing, but I just don't understand like what you're doing into like the word problem part.
Yeah.
I get it, but I.
Okay, so here's what you need to do. Let me tell you how this works. Will this lesson go up to Teams, to YouTube? Yes. Do you have a copy of the homework? Is it on there? Do you have the answers? I put them up there. What you do is you try it on your own, and you do it again, and you think about it, and you stare at it, and you think about it, and it eventually will come. If you revisit it over and over again, you will get it. It's just you didn't get it the first time. By the way, nor did I. I had so much trouble with this. It was ridiculous. So I completely understand where you're coming from, but you're gonna have to revisit this a few more times. And the great thing is we still have another class to prepare for the assessment. Okay. So, but I understand exactly what you're saying. To go from here to here and do it right, it seems like it's a big goal. But this is what we're doing right now. I'm exposing you to this again. And then we'll expose it again. And hopefully, if you have sufficient discipline and you want to, you spend some of your own time, and maybe in that time you discover something. And then I'm here to try and help push again. You ask the question and we repeat. In an ideal world. Got it? And in a not so ideal world, what we have people pretending to care when in reality they don't care consistently enough to matter. Fair enough? And how do we know you care? Because you consistently show that you're trying. And that's something that's personal. That's something that you have. And that's why you'll end up at MIT or something. Okay, so before I go on to the next problem, which is, in my opinion, an easy problem, I want to go ahead and explore this problem a little bit further to expand a little bit. Okay, so here, I'm going to go ahead and drag this over here a little bit, zoom it out a little bit from my point of view. Wait, let me zoom it out. And then I want to make a little table. I want to make a table that says truck. And I want to make a table that says not truck. And then you have Ford. And then you have not Ford. And then it means not. This means not. So it's truck or not truck. Ford and not Ford. It's squiggly line, yes. Okay, so let me ask you, what is the probability of truck? You can look at the area over here. So 1/6. What's the probability of not truck then? No. Not truck will be 5/6 because when we add the two probabilities, it has to equal to 1. The sum of all the probabilities has to equal to 1. If 1/6 of the people said trucks, then 5/6 said no truck. And if 3/10 of the people said Ford, could you tell me how many tenths said not Ford? 7/10. So far, so good. Let me make that 3 a little bit better so everybody's. I wonder if Alex is still there.
No, I'm not.
All right, is Jason there?
Mister, I've been here.
Awesome. All right, so there we have it. Now look, we figured out in this question here, we figured out that the probability of Ford and truck is what? 1 out of 15. So that goes right here. Ford and truck is right there. So far, we're almost done filling up this table. And there's a reason why I'm doing it, because when we're done, you'll see. So far, we started with 3 pieces of information, and now we're almost done filling out a full table here. Okay? So if you want to figure out this guy here, for example, you would take 1/6 and subtract 1/15. 1 divided by 6 minus 1 divided by 15. That's going to be 1/10. And if you take 1/15 and you add 1/10, you're gonna get 1/6. In that same fashion, you're gonna be able to get the rest of the things you need. For instance, if you want this guy here, you could take 3/10 and subtract 1/15. Right? Because whatever is here plus here has to give you that. So if I want to figure that out, I just subtract this from that. All right, so let's do that. I'm gonna just do it with my calculator. When I take 3 divided by 10 minus 1 divided by 15, I get 7/30. 7/30. And then if I want to figure out the last one, I can just take 7/10 and subtract 1/10. That's 6/10. Let me just make sure that 5 divided by 6 minus 7 divided by 30 also gives me 6 cents or something like it. It gives me 3/5, which is 6 cents.
How did your calculator do that?
Which one? How does my calculator do it? I just put it in there.
What the hell?
Like, look, 5 divided by 6 minus, and then with this one, I go parentheses 7 divided by 30, close the parentheses, and it gives me that.
It's a bougie calculator.
This is a TI Inspire, bro.
So bougie.
How much was that?
Like 100 and something.
$100 for a
More than
calculator?
100. No, 100. Come on.
It's literally gonna do the same thing as like.
No,
No, that one does like.
no, you don't
There's
understand.
like decimals.
No, no.
Like fractions and stuff.
Tell you.
$5.
No, I'm gonna use this calculator next time.
It can do everything. All right, but listen, we're not done. Look, here's the amazing thing about this. Let's go back to the original problem. How many people did we survey? 510. So let me create another table. And this is where I want you to see something. I want you to see something.
This was an easy question.
Yeah, well,
Oh my God.
the next one's easier. And you'll see why. So I'll create the table again. Truck, no truck. Ford, no Ford. We have 510 people we surveyed. Right? Everything has to add up to 510. If I take 510 and I multiply it by 1/6, wouldn't I get the amount of people who answered truck? Yes. So let's go ahead and do that. Take 510 and multiply by 1/6. Oh man, this calculator. Brianna was right. It's not a good one. Oh my gosh, I messed up again. Se apagó. All right, so what's 510 times 1/6? 80. So how many people answered that they own a truck? And now if I take 510 and subtract 85, wouldn't I get the amount of people who said they didn't own a truck? Yay. So now, can I take 510 and multiply by 3/10 to figure out how many people answered Ford? Yes, I can. So I take 510 and multiply it by 3, but then divide that by 10, and I get 153 people. And if 153 people answered that they own a Ford, could I figure out how many people did not own a Ford? 510 minus 153, and that's 357. And then now, if I take 510 and multiply it by 1/15, wouldn't I get the amount of trucks amount of people who had a Ford and a truck? This here represents I have a Ford and it's a truck. So now I take 510. I'm gonna divide it by 15 because it's a shortcut for that. There's 34 people that answered that. And then you take 153 and subtract 34, and you get this guy. And you take 85 and subtract 34, and you get this guy, and you take 425 and subtract 119, and you get this guy. And look what we've done. We began with 3 pieces of information, and we ended back with a freaking survey. We know now that there's 85 people who answered truck, 425 people who don't have a truck, 153 people who own a Ford. A 357 people who don't own a Ford, 34 people who have a Ford and a truck, 119 people who have a Ford, but it's not a truck, 51 people who have a truck, but it's not a Ford, and 306 people who don't have a Ford and who don't have a truck. And we created that from, well, you could say 3 pieces of data, actually 4, because we need to know how many people were in the survey to figure this out. And so the reason I went through that trouble is because now we go to this question here, and this question here starts with the table. Instead of starting with, that's why we need to know how to do the other stuff, because we can create tables with the other stuff. And once we know how to do that, then the table's super easy. Because if you look at the questions here, they're so simple. Look, find the probability that a randomly selected family is not taking a summer vacation this year. So what's the probability of not vacation? Well, how many people here? Well, first of all, look at the table. The table asks 2 questions. The table asks 2 questions. If they own a computer or don't own a computer. And if you're going to take a vacation or not in the summer. So let's just analyze the table for a second. How many people are taking a summer vacation this year? Not taking it? How many total people were asked? How many people own a computer? How many people don't own a computer? Okay, so now let's answer the first question. What is the probability that people are not going to take a vacation? No vacation this year. 45 out of 146. Perfect. So can you tell me what the probability of vacation is? How many people are going to take a vacation? Perfect. Now, what's the probability they own a computer? What's the probability they own a computer? No? 57. Do you see that? She's looking at this. What's the probability of not computer? 89 of what? You gotta continue. You gotta say the whole fraction. Okay, so now let me do this one verbally. Well, I can write it. It doesn't matter. What's the probability of computer and vacation? They have both a computer and they're going to take that vacation in summer. There are 46 out of 146. That's what that means. What's the probability they have a computer and they're not going to take a vacation? 11 out of what? Okay. What's the probability they don't have a computer, but they're going to take a vacation? And what's the probability they don't have a computer and they're not going to take a vacation? Great, fine and dandy. We're good with that. Now look at the next question I'm going to ask. What's the probability they're going to take a vacation given they own a computer? So
wait, before you go,
say which one?
the last you just said. Given.
Okay, so watch this. Probability they're going to take a vacation if they own a computer, given they own a computer. So you said what, Brianna? All right, so look, watch this. Watch what I'm going to do. If they own a computer, probability vacation, if they own a computer, probability of vacation given they own a computer. So here's what we do. You see, own a computer here? That's the given. I'm saying, hey, those of you who own a computer, line up. Everybody else, stay here. Then I go to them. I ask them the question, how many of you guys are going on vacation? How many are there going to go on vacation? Out of how many total? That's what the conditional does. That's how the conditional works. You see it? Now, remember having that same feeling you had and understanding that in class, but then when I took the test, I completely forgot. I couldn't, I'm like, why am I so dumb? I can't remember this shit. So I remember that vividly.
So it's the probability of them that they're gonna go on vacation.
Given
That they.
on the computer, correct.
It's always what you're doing.
Yes, the given is what reduces the sample space. Okay, so let's try another one. So I'm gonna erase all this stuff I wrote here. I'm gonna go ahead and go probability of not computer given not vacation.
So you would. Yeah.
So what's the condition here? What's the conditional? Not what? What's the probability they don't have a computer? You see it? Yeah, you see it? Does that make sense? Let's try another one. I flipped it on purpose. Now what I did again. What's the probability computer given vacation?
Line them up.
I'm doing it in my head, like the little shaded.
Okay, say that again. Computer given vacation. All right, so where's our vacation? Oops, wait, give me a second. So here's vacation. What's the probability to have a computer? Out of how many? There you go. You have to just be careful. How do we be careful in this? We practice. It's very easy to mess up, but once you understand it, you shouldn't mess it up anymore.
Yeah.
Now, look, guys, I'm interested in you getting good grades on the test, of course, because it shows me progress, but don't feel sad if you mess up as long as you understand the concept. Fair?
Can the test speed that?
The test is, you're gonna see the reviews I gave you.
I don't trust.
No. That ruined my confidence. The one from.
I don't know if the reviews will be the same.
Yeah. I don't know. You kind of lost my trust.
Everyone failed.
It's okay.
And I'm pretty sure you said there was only one kid that got an A in the entire class.
You got an A.
I got a B, not an A. No, I'm saying an A out of all his classes. Was there already one A?
Yeah, there was Mr. Acosta here that sits here in second period or first period. First period is the one that got like a perfect A.
What's my last name?
Listen, he didn't. Yeah, his last name was Acosta.
Of
He didn't even
course.
look. He didn't even study for.
Of course.
He didn't even
It's
study.
probably him back in
He
time.
did not study for his SAT without a single day, and he still got a 12 A. He was only
Some people are smarter.
20 points off.
That's, but, you know, I get it. I
Yeah,
understand.
he's a test taker. Like, he can-
He's good. So what? Just keep on trying your best. All right. Guys, I think that's the best I can do. I hope the review was enough for you. I'm gonna go ahead and update this into YouTube and then put it on Teams. If you want, do you have any questions from the homework? Those of you who did the homework that I can clarify right now. I did those? Okay. All right, so wonderful people. Just let me go ahead and put this on there. You guys, any questions there online?
A couple, but I'll figure them out. They're into bed.
Okay, now remember, I put the answers online. Please have questions for me next class. And that's pretty much it. So I'm gonna end the Zoom, guys.
All right, bye, mister. Have a good one. Stay
Take care.
safe.
You too. Take care. Have a great weekend. Stay safe, guys.
See you next week, hopefully.
Yes, take care. Yes.